answers to this one. I kind of just briefly showed it yesterday. Some people find it easier, some don't understand it at all. So I'll just show it kind of quick, and if you don't like it, well, then just ignore it. It is a very unofficial method, though, because there's no real work to be shown. So the unofficial method is you actually just plug in negative infinity and positive infinity. So let's take this top one. 3/2 to the infinity minus 1, that's bad too, whatever, minus 3. Okay? 3/2, if I keep multiplying 3/2, the answer is going to get larger because it's bigger than 1. And so 3/2 to the infinity power would become infinity. The minus 1 does nothing at all because, like, 10 billion minus 1 is still basically 10 billion. So whenever we have regular numbers like added, subtracted to infinity, they don't affect the answer. So infinity minus 1 is the same as infinity. So 3/2 to the infinity power would be infinity. Infinity minus 3. Minus 3 is not going to change that answer. It's so big that subtracting 3 is the exact same answer. So infinity minus 3 would be infinity. If I plug negative infinity in, so this is basically what you do when you have a limit with a regular number. It's just for infinity, it's not like an actual number, you just have to figure out the idea or what it should be. So 3/2 to the negative infinity minus 1 minus 3. Minus 1 again won't affect negative infinity, so I just ignore it. 3/2 to the negative infinity. Somebody gets to go. Hello? Hello? Hi. No, she is in a different fifth hour. I think she is in the Sullivan's room. Yep, bye-bye. Oh yeah, so 3/2 to the negative infinity, you could do it two ways. You can make it 1 over 3/2 to the infinity, or what we kind of talked about yesterday is if you swap a fraction, then it changes the power from negative to positive. So we could write this as 2/3 to the positive infinity instead. Every time you multiply 2/3, the answer gets smaller and smaller. So 2/3 times 2/3 would be 4/9. Times 2/3 we get 8/27. And your answer gets smaller each time because this is less than 1. And so if I do this an infinite number of times, getting smaller each time, this turns into 0. It gets smaller and smaller so that it's basically nothing. And then 0 minus 3 is minus 3. And those should be the same answers we got yesterday. Hoping there. You didn't write them down?
This is lesson 6.
Oh, okay. You say I'm doing all this writing and work. It's not for me.
Oh, no, that's not.
Success.
Good job.
I generally like this method better for me because it's less work. Like I can do it in my head. Where the sketching method, you have to draw a sketch. Like you have to try to think the steps in your head. So some people, this way makes 0 sense. And if that's you, that's fine. Do it the way I showed it yesterday. Some people like this because they can just kind of figure it out along the way. So anyway, that's just another method. 1/6, you'll probably like. Because it's not so much algebra heavy. So it's about continuity. I think we talked about this the other day. Does anybody remember how you could describe something as continuous to somebody else?
You can draw it without lifting
Yeah.
the pencil.
If you can draw something without lifting up your pencil, that's how most people in their head think of continuous. Okay? Where we talked about it, I think, was when we were doing polynomials. I don't remember what it was for. I don't remember. We were talking about asymptotes or something, probably. But we just basically talked about it very shortly. Well, there's going to be different kinds of continuity. And for calc, you generally are going to look if something is continuous at one spot, which sort of doesn't make sense. But that's what we do. This whole first page is pretty much nothing. I mean, we got a picture, and clearly the picture has a bunch of things that aren't continuous. Page 2 is where we describe what they are. Why is it on top? There are two main types of discontinuities. Can anybody think of an easy way to describe, well, never mind, it's written right there. Let's not. So removable is going to be the phrase that you'll use. A removable discontinuity can only be done one way, and that's with a hole. They call it removable discontinuity because a single point was removed to create a discontinuity. So we basically think of it as holes. That's the only way you can have a removable one. The other style, non-removable, has two types, even though they're kind of the same. One type is called a jump discontinuity. Shoot, I'm trying to think of the other name I've heard for it. Textbooks don't use the term jump discontinuity. Can't think of it. It's not going to matter for us, but still, it's nice to know the other term. A jump discontinuity is when there is a gap between pieces of your function. And so there is a jump between the pieces. Generally, you're only going to see this from piece functions or piecewise. That's pretty much the only way you'll see it. You can have a different, like, that take-home quiz, one of the questions I erased was a step function, because I don't believe we've had a step function in the homework yet. Did you guys have those last year? Or maybe they were called greatest integer functions? It basically was little lines that make steps. Do you remember what you call them? I don't know what the new pre-calc textbook calls them. The equation has like a double line bracket. There's different names for it. Jump function, step function is one name. The other name is the greatest integer function. Maybe round down function. I know your calculator calls it I believe it's the round down function. Textbooks usually called it the step function or greatest integer. Basically, the graph looks like this, where one side of the line is a solid dot, the other is a open. So I took this off of your quiz. The question that was going to be asked was finding the limit at one of the integer values. But because judging by your reactions, we have not had one in the homework yet. So, a step function is another way you can get a jump. And then the infinite ones are usually pretty straightforward because they're generally from vertical asymptotes. And an infinite discontinuity just means that your graph points to infinity. So this one is kind of a combination of both. I'm mainly going to be looking for you to know if something is removable or non-removable. This is what the AP test cares about. For something to be continuous at one spot, one point, the limit from both sides and the function value in the middle have to be the same answer. Which, mentally, I think you kind of already know what it looks like. If something is continuous, it just keeps going. So the limit from both sides and the function value are the same answer, that's continuous. So if you get a free response question that involves continuity, this is how you have to prove it. And by proving it, you basically just have to say, like, the limit as x approaches 2 of f of x equals f of 2 equals 8, or whatever the height is. And it's not necessarily like a proof, but on the AP free response, they want to know that you know what to look for. So that's how you would show it or prove it. Nope. These are things you don't need to memorize. You can if you want. Okay, let's do a question together. I thought this would be the best way to learn the differences. For c equals -3, oh, wait, somebody here want to roll? Okay, you were quick today. Have you already rolled? Okay. You want dice or bingo? There you go. Oh, I gave them back. Yeah, there it is. Okay. So we're basically looking at 3 different numbers, and then we're supposed to find the function value, the limit on the left, the limit on the right, and the two-sided limit, and figure out if it's continuous at that location. $18. Who's 18? Right there? Okay, we're going to do -3 first. So there are 3/4 things. We want to find f of -3. We want to find the limit on the left of -3. And then on the right. And I was hoping you could help us find that. And then these two together are the two-sided limits, so it's sort of a fourth. But you don't have to do the two-sided ones separately. All right, let's start with f of -3.
Is it 2?
Is it 2? So I go over to x equals -3, and the open dot means that it's not there, but it is right here at a height of 2. That's a good start. It's a good start. Build your confidence.
Coming from the left, -1.
Good.
Coming from the right, -1.
Okay, so two-sided would also be
-1.
-1. Okay, good. Is it continuous at -3?
Yes.
No.
No. No.
Okay, it's definitely no. Like, looking at the picture, it's definitely not. There's a hole. Okay? How come, no, let me phrase it differently. what do we need to have happen to make it continuous at one spot? The limit has to be the same as the function value. So what didn't happen here?
They weren't the same.
They were not the same. Okay, good. Essentially, all four of these things have to be the same number, and then it would be continuous. So we would say it is not continuous at -3, or looking at the picture, well, it's clearly not. I would have to lift my pencil up to go to the next section. Okay, good job. I mean, that was a pretty good job because I basically said nothing in help. Nothing in help. Not one.
25.
Okay. Nobody. 22? Oh. You're just making everybody else get extra nervous.
7.
Okay. What type of discontinuity exists at -3?
Removable.
A removable. Excellent job. And you guys do have your notes to use. That's partially why we write it down and highlight stuff. Good start. So we would say a removable discontinuity at x equals -3. I don't have the room for this, so I'm just gonna. You guys write small. Excellent. Let's go to the next person. You look like you're enjoying making people answer. 11. Where is that? At c equals +3 or x equals +3. So over here. So I would need to find f of 3, limit at 3, etc. Okay, what's f of 3? What would be the height of the graph at 3? It definitely doesn't say. I'm trying to think how I can phrase the question without just saying the answer. I feel like you're just absolutely overlooking the obvious. Right. There isn't f of 3. There's a vertical asymptote at x equals 3 because both sides just go up. And so it does not exist at 3. We can immediately stomp right there because we're definitely not going to be continuous. Continuous has to have a number answer, and if one of them doesn't exist, it can't be continuous.
On the test, do you still want us to go through all of them?
No. If one of them does not exist, you can just stop. What on earth? I've got nothing. Grab the box.
15 minutes.
Yeah.
17.
What type of discontinuity is at 3? I don't have your room to write that, but. No. So that's what we're looking at. What does that match on those pictures?
I don't get what you're trying to ask.
Oh. Well, I'm writing the answer. I thought you were gonna say it while I was writing it.
Out of removable, infinity, and jump discontinuity, which one is that?
Well, yeah, I hope so. I was just gonna say, how come it's non-removable? Or, sometimes it's much easier for people to know which ones are removable. Removable can only look like one thing. A hole. So that one's removable, that one's removable, that's not. But a vertical asymptote is a non-removable and can be called an infinite non-removable. Okay, good? Do I need to do the last number? Or should we? Whatever we want to say? Yeah, okay, yes. So at 7, so we are looking at this dotted line. We are checking if things are continuous. So what is f of 7?
3.
Good, yep, solid dot to 3. Limit to the left of 7,
3.
yep. Right,
3.
no. I think you got in the habit of just saying 3.
Oh. 6.
Yes. Okay. The two-sided limit does not exist. And the fact that all of these were not the same answer means it is not continuous. What kind of discontinuity happens when there's a missing chunk? I'm not sure how to say it differently. There's only 3 kinds.
Oh,
It's true.
jump.
A jump. So this is a jump discontinuity or a non-removable discontinuity. To be honest, the multiple choice questions, sometimes we'll just want to check if it's removable or not. Sometimes it might ask you, for more specific. So you just kind of have to know the difference. What's going on there? You also may get questions asking you to draw a function with a jump discontinuity, and so you would need to know what that would look like on a graph. That has definitely been on our tests in the past years. Okay, now we no longer have a graph. Whether that's better or worse, I don't know. Probably worse, but we'll go with it. 30. Yeah. Follow along right with us.
Yeah.
We are trying to figure out where this function is discontinuous and what type of discontinuity it would be.
At 3.
Oh.
Non-removable.
Okay, wait, slow down. I hate writing discontinuous and discontinuity. Just go. Nice trivia. Discontinuity, it's so long.
How do you spell it?
Well, dis and then continuous.
Oh, it's extra U.
I think so.
No, I was
Saying-
calling discontinuous.
Yeah, that's right. I'm making me doubt myself here. You were 100% correct. How did you know it was discontinuous at x equals 3 though, just immediately?
Oh, who knows? Because either is a whole.
No.
No, not a whole.
Yeah, it was okay.
Absolute whole.
So any number that makes the denominator to be non-existent, like does not exist, would make your function discontinuous. So if you have a square root, you can't use negative x values because those wouldn't be real, they wouldn't exist. You're just looking for where things happen. If this was just a regular polynomial like that top one, well, there isn't any. It's just a regular parabola or whatever. So we're looking for numbers we can't use. So it would be discontinuous at 3, and then I think you were starting to say what kind? What kind of discontinuity is it?
I said.
I think you said whole at first, and then you corrected yourself. Just grab the box. Okay, go ahead.
Oh, I said removable.
Oh, okay, how come?
Because there's a hole there.
Oh, that's not true.
Uh,
I mean, you approached it perfectly and like, you said it confident and I loved it.
like, I got like half it right.
You did. So my guess is you have the difference between holes and vertical asymptotes mixed up in your head.
I said vertical, but
You said a hole.
I said that before.
Wait, so you said both?
Yeah.
Can't be both. A vertical asymptote is a factor that remains in the denominator. A hole is a factor that cancels. Okay, so this one stays in the denominator, so it is a vertical asymptote. That would be an infinite. Why have we done that? Infinite discontinuity at x equals 3. A lot of writing just for the same thing 3 times. Okay, now who gets B, because that's way more work.
16.
16. I don't think she's gonna forgive you for that. Okay, how do we, I don't know, anything,
Factor that's all.
okay? I'll show you guys the quick way again. You guys are smart, you can do this one.
I like this whole time.
2x squared. There's only one way you can make 2x squared. 2x and 1x. 6 has a couple options, but we can do them quick in our head, so we'll do that. We need to make 7. Everything's positive. So it's either gonna be 6 and 1 or 3 and 2. Now, I kind of know 6 and 1 isn't gonna work, because 6 and 2 would make 8. And if I put 6 over here, that would make 12. So it's gotta be 3 and 2. So I'm just gonna try 3 and 2. If it doesn't work, I swap them. Okay, well now I've got 4x and 3x. That makes 7. The middle term always comes from the outsides and the insides, like FOIL. You guys look like you don't remember a lot of that.
Can you like go over factoring quick? Like when there's a like when there's a number in front of the 2x squared.
Alright, so you're basically not getting work time, but I'm okay with that.
No, we're not okay with that.
Coefficient of the first one.
You're not the only one that needs to see factoring, you're just the only one brave enough to ask for it. Multiply the outside numbers. Find the factors of 12 that add up to 7. 3 and 4. As soon as you find the correct pair, you put it in place of 7. And it doesn't matter what order you write them. Split it in half, do factor by grouping. X is the only thing in common. 2 is the only thing in common. Both sides have 2x plus 3 in common. And then you write what was in front of both of them in the other one. And you got the same thing I did up there in 10 times the length of time.
I didn't know how to do this until I checked it last.
Just gonna tell you right now, you don't wanna use this method. It's gonna take you too long, you're not gonna finish your tests. When you get to the AP test, you are given 1 minute 58 for each multiple choice question. And you're given 15 minutes for like a 4-part free response question. You don't wanna take the time to factor like this.
Okay, but like the other way doesn't make sense to me though.
But figure it out. I mean, practice, I don't, whatever you wanna do, like, however you gotta do to make it quicker.
Yeah, I'm cool. I'll just get better at the other method, then it'll be really fun.
It is really fast when you know how to do it.
But
I did the second method in my head fast.
I wrote it down, I did it faster.
Okay, cancel. Okay, you had the perfect start. Now do it. Okay? Now, you are not wrong, and that is perfect. It's just not what they were really asking for. So you described it perfectly, but this isn't what we would answer. So the answer, up here it says, describe the type infinite or removable. Justify your answer by using the above. So a whole can only be one thing. A whole can only be removable. Perfect. And when you guys get a question on a test, it generally will have directions like this to give you some guidance as to what kind of answer you're supposed to be getting. So removable discontinuity at x equals -2. Now, if we wanted to use the definition, I skipped that part because it's so much extra work. But the definition of continuity would mean we'd have to find f of -2, and then the limit to the left of -2, the limit to the right of -2. And f of -2 doesn't exist, so immediately we have no continuity, but we kind of already knew that, so. And then the limit at -2 would be plugged in to this equation. Okay, I think that was all the farther I wanted to get in 1-6, because the next part of 1-6, yes. Okay, well, that's piece function stuff. And I'll hold off till Monday for that, because that's kind of its own topic, and we'll take a little time to talk about, because I'm sure you guys don't remember piece functions perfectly, so. You definitely did piece functions.
You are set up better for this stuff than